Factories drifting above the earth, turning weightlessness into profit, sound like the sort of thing you'd hear from a man who's read too much science fiction. Yet companies are actually preparing to build satellites, optics, and even industrial materials in orbit. The ground is getting crowded, and space is beginning to look like the cleaner workshop. Stick around, because the way we build things might be heading upward. Hello, my name is Gene Botkin. I'm a cybersecurity analyst working in the space domain, and I'm building a club for people who want to participate in the new space economy. Our topic today is the emergence of an industrial age in orbit, where manufacturing drifts off the factory floor and into microgravity. Let's begin. The whole idea started the way many big ideas do, with someone looking at a very expensive piece of hardware and saying the quiet part out loud. Why do we keep smashing these things into orbit, fully assembled, when we could build them up there and stop pretending that gravity is a helpful colleague? The room probably fell silent, in that way that meetings do when someone says something that makes too much sense. After all, the space sector has long run on the principle that tradition matters more than physics, and that engineers should embrace stress as part of their spiritual growth. The traditional model goes something like this. You design a satellite, you pour money into it, you polish it until it gleams, you put it on a rocket and hope that it survives the ride. The whole process resembles shipping a grand piano across the Atlantic during a storm and praying that it hits the right notes at the end. People accepted this because there was no alternative. Then the smaller satellite movement arrived, and everyone pretended that they had always liked quick builds and modest price tags. It was as if the industry discovered thrift after 3 decades at the diamond counter. These smaller systems made space feel accessible. They made it feel like a place where scrappy newcomers could show up with a toolkit and compete. Yet even those machines carried limits. You could mix and match components, but the overall shape was fixed. So here comes the third route, the one that feels like a plot twist from an engineer who had a little too much coffee. Why build the whole satellite on Earth when you could carry up the pieces and assemble them in orbit? The idea seemed reckless at first, almost like suggesting that we run a shipyard in the middle of the Pacific while standing on floating wooden pallets. Yet the more people thought about it, the more it appealed. After all, space does one thing extremely well. It removes weight. With weight gone, you can shape materials with a light touch. You can twist, mold, and refine things that feel stubborn on Earth. Companies began to test this idea. Some tried growing crystals that form more cleanly without gravity pulling them around. Others experimented with molding lenses from liquid polymers. Picture a bubble of material floating quietly in a lab module. There is no sagging, no warping, and no grumpy technician trying to fix the slightest ripple. The result can be startlingly smooth. And some early lenses had surfaces measured in fractions of a nanometer. This is the sort of measurement that encourages engineers to whisper to each other like gossiping parishioners. The promise of these results set imaginations running. If you can shape small optics, then why not shape large ones? If you can build a lens, then why not build a mirror array the size of a tennis court? The usual obstacles have always been launch sizes. Rockets do not care how majestic your telescope dreams may be. They have fairings, and those fairings have opinions. But in orbit, the sky is literally the limit. They have fairings, and those fairings have opinions. But in orbit, the sky is literally the limit. You can assemble a mirror, bit by bit. You can stretch trusses that would snap under their own weight on Earth. Engineers looked at this and felt the same awe that a carpenter might feel after discovering that wood no longer splinters. Ambition grew, and soon people were discussing orbital factories. The phrase sounded fanciful at first. Factories belong in old photos with smokestacks and tired workers taking lunch breaks on overturned buckets. Yet the idea kept persisting because it fits the new era that is forming. If you want satellites faster, cheaper, and easier to modify, then the best place to make them might be the place they will live. It eliminates the need to build everything on Earth and pray the rocket does not shake it into retirement before it switches on. A few studies explore what this shift could mean. One analysis found that several Earth observation instruments, originally built as separate large satellites, could have been combined into a single orbital platform assembled in space. That approach would have reduced launch requirements and saved a remarkable amount of money. The numbers circulated through conferences and caused a quiet pause among the serious types who carry notebooks and whisper about cost curves. Think of it this way. Instead of building a full satellite and sending it up for a one-shot career, you build a platform that evolves. Need a new sensor? Send up a module. Need more power? Add a panel. Need repairs? Let an orbital technician vehicle do the work. The satellite becomes less of a fragile heirloom and more of a living workshop that grows with the times. The whole system begins to resemble a construction site at high altitude where nobody complains about ladders. Plenty of companies now want a role in this future. Some develop tools for assembling large structures. Others focus on printing components. Some dream of refueling services. A few want to recycle dead satellites into raw materials. If any of these succeed, then they could create a flywheel effect. The presence of one orbital surface encourages the next, and before long, you have an ecosystem of machines that depend on each other the way old fishing towns depended on every link of the catch. Progress in this field moves with the slow patience of a glacier. The tests are promising, but the leap to commercial reality remains steep. Launch costs may be falling, but they are still high. There is also the question of demand. People love the idea of space manufacturing, but somebody has to buy the products. And if the materials made in orbit truly outperform those made on Earth, then customers may line up. But if the improvement is small, the overhead might outweigh the charm of microgravity craftsmanship. There is also the matter of regulation. Space law was written for an era when satellites behaved themselves. Now that people want to build factories in orbit, the lawyers are gathering like clouds. They want rules for ownership, liability, debris, quality control, and the returns market for products made in space. Investors tend to wait when lawyers start drawing maps. Nobody wants to be the first company caught in a legal quagmire with a warehouse full of flawless space crystals and no permission to bring them home. Still, the momentum is real enough that serious leaders in the field treat industrial space manufacturing as a likely part of the future. They see a transition forming from bespoke craft to industrial capacity. They see a world where satellites are born in orbit rather than carried there like fragile antiques. They see telescopes with mirrors built far larger than the ones that fit inside rockets today. And they see solar farms constructed high above the atmosphere. They even see the rough outlines of orbital shipyards that maintain vehicles the way coastal towns maintain fishing boats. If even part of that vision forms, then it could change the character of space. It would no longer feel like a sparse frontier, and it would instead feel like a working zone full of machines that cooperate across distances. It would feel like a place where human ambition moves from exploration to production. And there is something bracing in that shift. People have romanticized space for generations. Turning it into an industrial arena brings it closer to normal life. It makes it familiar. It makes it a place where work happens. A funny thing happens when you talk to insiders about this idea. They tend to smile in a way that suggests they have seen a glimpse of something grand and slightly absurd. They know the challenges. They know the costs. They also know the potential. There is a sense that the world is entering a gentle pivot from seeing space as an archive of distant dreams to seeing it as a workshop filled with opportunity. Someday, children might grow up hearing about orbital foundries the way older generations heard about steel mills. They might know about companies that produce materials among the stars, and they might treat the whole affair the way we treat cargo ships and factories today. Normal, necessary, and part of life. But for now, we are watching the early sparks, a lens molded in microgravity, a truss assembled by a robot, a crystal that forms with elegance unseen on Earth. Each small step adds weight to the broader idea that orbit can become a place of industry. And if that happens, the era of launching fully assembled spacecraft may come to feel as antiquated as shipping a piano across an ocean and praying that it arrives in tune. If you're still here, you already know that the sky is getting crowded with more than satellites. It's filling with the early outlines of an industry that might feel ordinary sooner than anyone expected. If you want to track that shift or take part in it, then you're in the right place. So like the video, leave a comment, and subscribe to the channel. This has been Gene Botkin with Elenarda. End transmission.